Hi, my name is Diana and I'm going to teach about direct, joint, and inverse variation. Now, the first things we need to know about are the variables, what they stand for. So there is K, and that is the constant of variation. And there is X and Y. And that's direct variation. So direct variation is the relationship between two variables which can be expressed by an equation in which one variable is equal to a constant times the other. So in other words, y equals kx. And that's your equation for direct variation. So in order to solve for the equation, we have to go through some steps. And the steps are, number one is to write the equation. Two is to plug in numbers for the variables. Three is to solve for k. Four is to use k to solve for unknown. And final step is to solve for the unknown. And those are the steps for direct variation. So now we have both our examples for direct variation, now we have to solve them. So the first one says, if y varies directly as x and y equals 15 when x equals 3, find y when x equals 12. So the first thing we're going to do is we're going to do y equals kx, because that's the equation, in the numbers for the variables. So we have 15 equals k3, and now we're just going to solve for k, so we're just going to divide by 3, and we're going to get k equals 5, and then we're going to use the 5 to plug it back into the equation, and it would be y equals 5 times 12, because 12 was x, and we're just going to solve for it so that y equals 60, and that's your final answer for this equation. So now the next equation asks for us, if y varies directly as x and y equals 8 when x equals 6, find y when x equals 15. So we're going to write out the equation, so it's y equals kx, and we're going to plug in the numbers for the variables, which is 8 equals k6, and we're just going to divide the 6 both sides. 6 divides out to be 4/3, so k equals 4/3, and we're just going to write out the equation, so it's y equals 4/3 times the 15. The 3 and the 15 cross cancel, so it's 5, and y equals 20, since 4 times 5 equals 20. And that's your examples for direct variation. So the next thing we're going to learn is joint variation. So the equation for joint variation is y equals kxc. Joint variation is when a quantity varies directly as the product of two or more quantities. So the steps to solve for a joint variation type of problem are as follows. So the first one would be to write out the equation. 2 is to plug numbers in for variables. The third step would be to multiply the x and z. 4 would be to solve for k. 5 is to use k to solve for unknown. And lastly is to solve the unknown. And those are your steps for joint variation. Now that we know what joint variation is, we have to do some examples, and the first one says, suppose y varies jointly as x and z. Find y when x equals 2 and z equals 27 if y equals 192 when y equals 8 and z equals 6. So we're going to start out by writing out the equation, which is given to us. Y equals kxz, and we're going to start by plugging in all the numbers for the variables. So it's 192 equals k times 8 times 6. So we're going to solve for the x and z, and that's 48. And if we divide the 48 and 192, k equals 4. We're going to use the 4 to solve for the unknown, and we would be given y equals 4 times 2 times 27, and that would give you a product of 216. And that would be your answer for the first question. Now the second one says, if y varies jointly as x and y equals 80 when x equals 5 and z equals 8, find y when x equals 16, z equals 2. So we're going to start up by writing out the equation. Y equals kxz, and y is 80, and k is not known, x is 5, and 8 is z. So we would solve for k, and k would equal 2 when we multiply out the 40 and divide it by 80, and would get 2. So then we would plug in k for the rest of the equation, and it would be y equals 2 times 16 times 2, and y would equal 64. And that's your answer for the second equation. Last type of problem is inverse variation, and the equation for that is k equals xy. Inverse variation is the relationship between two variables which can be expressed by an equation in which the product of two variables is equal to a constant. So the first step is to write out the equation. The second step is to plug numbers in for variables. Thirdly, we have to solve for k. We have to use k to solve for unknown. Fifth and last, we have to solve for the unknown. And those are your steps for inverse variation. So we're going to do our last examples, and therefore inverse variation. The first one says, if y varies inversely as x and y equals 5 when x equals 10, find y when x equals 2. So we're going to start out by writing our equation, which is k equals x, y. So we're going to substitute all the values. So k would equal x is 10 and y is 5. So k equals 50. We're going to use the 50 to write it in our next equation, and x is 2 and the y is there. Y ends up being 25. So the next equation asks, if y varies inversely as x and y equals 16 when x equals 5, find y when x equals 20. So we're going to write k equals x, y. K is not solved for until we solve this problem, so it's 5 times 16, k is equal to 80. 80 equals 20y, and y ends up being 4. And that's your answer for inverse variation of example 2.